Next question. Evaluate line integration y dx plus z dy plus x dz where C is the curve of intersection of the sphere x square plus y square plus z square equal to a square and the plane x plus z is equal to a. Now to evaluate this, we have given the curve to be the curve of intersection of sphere and plane. As we know, when we cut the sphere by plane, the intersection will be a circle. So this is the curve of intersection, circle, which is the open surface S. So therefore, by Stokes theorem, integration over the closed curve C f bar dot dA r bar is equal to double integration del cross f bar dot n cap ds over the surface S. So let us evaluate del cross f bar. Del cross f bar is determinant of I cap, j cap, k cap, partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, y, z, x. When we evaluate this determinant, I cap times derivative of x with respect to y is 0, minus derivative of z with respect to z is 1, minus j cap times derivative of x with respect to x is 1, minus derivative of y with respect to z is 0, plus k cap times derivative of z with respect to x is 0, minus derivative of y with respect to y is 1, so minus 1. So therefore del cross f bar is minus I cap minus j cap minus k cap. Now this n cap is normal vector to the plane, to the circle, sphere actually, but that circle lies on the plane x plus z is equal to a. So this normal vector is normal to the plane x plus z is equal to a, is it? And as we know how to evaluate the normal vector to the plane, suppose if we denote that plane to be phi, so let phi is equal to x plus z minus a. So therefore n cap will be del phi upon mod of del phi. So del phi is I cap times derivative of phi with respect to x plus j cap times derivative of phi with respect to y plus k cap times derivative of phi with respect to z. So which is I cap times derivative of phi with respect to x is 1 plus j cap times derivative of phi with respect to y is 0 plus k cap times derivative of phi with respect to z is 1. So del phi is I cap plus 0 j cap plus k cap, and therefore n cap is del phi upon mod of del phi. So which is I cap plus 0 j cap plus k cap upon its mod. What is the mod of this? Which is root 2, because square root of 1 plus 1, which is root 2, and therefore del cross f bar dot n cap is minus I cap minus j cap minus k cap dot product with this n cap, which is 1 by root 2 I cap or I cap by root 2 plus k cap by root 2, and the dot product of these two vectors is a component wise multiplication, which is minus 1 into 1 by root 2, which is minus 1 by root 2, minus 1 into 0 because j component is not there, so 0, and minus 1 into 1 by root 2, which is minus 1 by root 2, so which is minus 2 by root 2, but minus 2 can be written as root 2 into root 2 upon root 2, so 1 root 2 will get cancelled, so therefore it is minus root 2. So the value of del cross f bar dot n cap is minus root 2. We substitute into the Stokes theorem, we get therefore line integration over the closed curve C f bar dot d r bar equals to double integration del cross f bar dot n cap ds over the surface S, which is equals to double integration del cross f bar dot n cap is minus root 2 ds over the surface S, so which equals to minus root 2 times double integration of ds over the surface S. If you look at this is nothing but area of S, so root 2 times area of S. But if we again consider the region, S is a circular disc, so area of S means area of circle, so minus is equals to minus root 2 times area of circle. Now to get area of this circle, we have to consider, or we have to get the radius first, because area of circle is pi r square. What is the radius of this circle? So to get the radius, by geometry we can get the radius. This is a right angle triangle. We have this to be the radius of the sphere, which is a. We can get this by perpendicular from a point to the plane formula. As we know, therefore, because this circle is lying on plane, so therefore perpendicular is equal to equation of plane. What is equation of plane? Plane is x plus z is equal to a. So equation of plane at this point, what are the coordinates of this point? 0, 0, 0, because this is center of sphere, which is 0, 0, 0. So equation of plane at this point, which is 0 plus 0 is equal to, actually minus a equal to 0, so 0 plus 0 minus a. So minus a upon square root of 1 plus 1, which is root 2. So the perpendicular is a by root 2. When we substitute this is actually a by root 2 and this is a. So by Pythagoras theorem, therefore by Pythagoras theorem, we get hypotenuse square, which is a square, is equal to r square plus this perpendicular, which is a by root 2 ka square, which is equals to, therefore r square is equal to a square minus a square by 2, which is a square by 2. So r is a by root 2, and therefore line integration over the closed curve CF bar dot dr bar is equals to minus root 2 times area, which is minus root 2 times pi r square, area of the circle, which is minus root 2 times pi into r square is a square by 2, so which is minus pi a square into root 2 upon 2 is root 2 into root 2, so 1 root 2 will get cancelled. The answer is minus pi a square by root 2. Thank you.